All right, so this question says at the moment a hot rod is plunged into freezing water, the difference between the rods and the water temperature is 100 degrees Celsius. This causes the iron to cool and the temperature difference drops by a decay factor of 0.6 every second. So the function t of s models this situation. So let's think about what we know so far about this situation. Well, we know that the current or the initial temperature that was given is 100, and we know the decay factor to be 0.6, and that's happening every second, and it's modeling by a function t of s. So let's move on with this information. So the initial value is 100. In order to calculate the remaining factor, because if it's decaying by 0.6 every second, we need to figure out like what the remaining factor is. And remember, if they give us, in order to find the remaining factor, what we would do is we'd have 1 minus the factor that it's decaying by, or the amount that it's losing. So 1 minus 0.6, which is how we're getting the 0.4 here. Therefore, the equation that models the situation that represents the remaining temperature after each second is going to be given by y is equal to 100 times 0.4 raised to the s. Now, one of the things they asked is where to calculate the remaining temperature when s, or the time, is -2. So what that means is that we're going to replace the s in the equation with -2, right? And so we have y equals 100 times 0.4 raised to the -2. This should really have been t of s. So we could have written this as t of s is equal to 100 times 0.4 raised to the -2. We've been talking about the fact that a negative exponent means the reciprocal of a number. In a decimal, what do? Every number, we can give it a denominator of 1. So we can say, oh, this is 0.4 divided by 1. When you have a negative exponent, it means you're taking the reciprocal of that term, so you're flipping it, and then you're going to raise it to the positive power. So we're just going to focus on this section right here. What does that mean? For us, what we're going to do is, it means that we are going to be flipping that 0.4 over 1, so that will become 1 over 0.4. So that means 1 divided by 0.4, and that's raised to the positive 2. So if we think about that, 1 divided by 0.4 is equal to 2.5. So that becomes 2.5 raised to the second power. So, or y is equal to 100 times 2.5 times 2.5. So y is equal to, we're going to do our exponent part first. So 2.5 times 2.5 is really 6.25. So we have 100 times 6.25, which means that y is equal to, when we multiply 100 times 6.25, we're going to end up getting 625. And what does this mean in the context of this problem? So what this means is that 2 seconds before the iron's first temperature was measured, it was actually 625 degrees Celsius. All right.